Hello and welcome back to Faceless Security, where we explore the world of technology and cybersecurity.
Have you ever really thought about what keeps our world running? You know, the power grids, the water treatment plants, the factories that make everything we use. Well, it's all run by a hidden world of industrial control systems, and they are basically the digital nervous system of our entire modern life. So today, we're going to pull back the curtain on this critical technology and show you exactly how we protect it.
Okay, I know what you're thinking. At first glance, this looks like a ridiculously complicated mess of boxes and lines. But this is the blueprint for how our world works. And I promise by the time we're done here, this diagram won't just make sense. You'll be able to see the invisible lines of defense that keep it all safe and secure.
So to make any sense of that big diagram, we have to start with the basics. And you know, the biggest challenge in securing these systems, it's not just about the technology, it's about the people who run them. Now, here's the official textbook definition of an industrial automation and control system, or IACS for short. But I want you to look closely. The most important word on this slide isn't hardware or software, it's personnel. Because at the end of the day, people run these systems, and that's where the really interesting security challenges begin. Okay, so just picture a factory floor for a second. The operations team, their one and only goal is to keep that assembly line moving. Uptime is everything. Every single second of downtime costs a ton of money. But then you've got the IT security team, and they're saying they need to shut everything down to install a critical security patch. See the problem? You have completely different teams with completely different priorities. Getting them to work together, that's the real key to securing these systems.
So how in the world do you get these different groups to even speak the same language? Well, for decades, the answer has been the Purdue model. It's a simple but really powerful blueprint that brings a little order to the chaos of an industrial network.
And here it is, the Purdue Enterprise Reference Architecture, or PERA. Now, this was developed way back in the 90s, and its absolute genius was providing this logical framework. It takes all these interconnected systems and neatly separates them into different levels, like a layer cake. It gives everybody a common map to work from.
The best way to think about it is like a pyramid. Way down at the bottom, at level 0, you've got the actual muscle, the sensors, the motors, the valves that are doing real physical work. Go up one step to level 1, and you've got the reflexes, the local controllers, the PLCs that make those split-second decisions. Level 2, that's the eyes and ears, the screens where human operators are watching everything. And then as you go up, you get to the brain, the corporate network, making all the big-picture business decisions.
And this right here, this is maybe the most important idea in the whole model. It's the line in the sand. It's the separation between the OT world, the operational technology on the factory floor, where a mistake can cause a physical accident, and the IT world of the corporate office, where the biggest risk might be a data breach. That separation has been the absolute cornerstone of industrial security for a very long time. Look, the Purdue model is a fantastic tool for understanding how these things are put together. But let's be real. It was designed in a different time, long before the internet and the kinds of cyber threats we see today. There's a famous saying in science, all models are wrong, but some are useful. And while Purdue is incredibly useful, well, it's time for an upgrade. And that upgrade, that evolution, comes from a modern security standard called ISA/IEC 62443. It introduces these awesome concepts of zones and conduits. Now, this isn't about throwing the Purdue model out the window, not at all. It's about laying a more powerful, more flexible security model right on top of it.
So first up, a zone. The easiest way to think about a zone is like putting up a digital fence around a group of devices that all have something in common. For example, all the controllers that run one specific production line. You could put them all in their own zone. That way, if something bad happens to one device, the damage is contained inside that fence. Okay, so if zones are like secure rooms with fences around them, how do they talk to each other? Well, that's where conduits come in. A conduit is a secure, controlled pathway between zones. It's not a free-for-all. It's like a guarded hallway where you get to decide exactly what kind of traffic is allowed to go from one zone to another.
So let's just boil this all down. What's the bottom line? Think of it this way. The Purdue model is the what and the where. It's the physical map of your network. Zones and conduits are the how. They are the security rules you layer on top of that map. You really need both to build a system that's truly secure.
And this slide really says it all, doesn't it? We're moving away from that old, rigid, top-down pyramid and toward a much more flexible, risk-based approach.
And that right there is a total game changer for security. Because when you start organizing by risk, you can focus your best defenses on protecting the things that truly matter the most. So how do you actually do this in practice? Well, you identify your assets, you group them together into logical zones, and then you connect them with these secure conduits. But here is the absolute golden rule. A conduit that connects a high security zone to a low security zone has to enforce the high security rules. No exceptions. A chain is only as strong as its weakest link, right? Same idea here.
Okay, enough theory. Let's roll up our sleeves and actually see what a secure industrial architecture looks like out in the real world.
All right, check this out. In this example, you've got the main control system, the BPCS, sitting in one zone. But then you have the safety instrumented system, the SIS, which is basically the big red emergency stop button for the whole plant. And notice it's in its own highly protected zone. Why? Because if that system fails, we're not talking about losing some data. We're talking about a potential explosion. That is what risk-based security is all about. And this diagram here perfectly shows off the conduits. See those green channels? They are the only, and I mean only, pathways for communication between the corporate business network, that buffer DMZ in the middle, and the two industrial networks on the factory floor. Every single piece of data that wants to cross between those zones has to go through one of those controlled, monitored conduits.
You know, we've come a long way pretty fast. We started with that intimidating diagram, and we broke it down into a simple, elegant security model. We've seen how the old Purdue model and the new concepts of zones and conduits can work together to build a truly defensible architecture. So the next time you see a factory or a power plant, you'll know that there's this hidden world of digital defenses working behind the scenes. And now, you've got the blueprint, you've got the tools. So I'll leave you with this question. How would you design it?
Thank you for watching. Be sure to like, comment, and subscribe for more great content from Faceless Security.